All right, let's do this. Hey, everybody. Welcome to this week's episode of AWS Step Functions. If you're coming back from Happy Little APIs, thanks for sticking around. I hope those latency problems that we had at the end there don't get us for this. If they do, just in case, I want to get it out there early that we will, both Eric and I will put our videos up on our YouTube channel later, okay? But hopefully we'll get this going today. As always, just drop your questions in the chat as they come up. You've got the links command here. We're going to be using some of these. You've got the repo command if you want to look at the code that we're building. Maybe that's turned off. Let's try the GitHub command. There we go. GitHub command will work better. And then docs. You always got to do the docs, right? You can save yourself 5 minutes of reading the docs by 4 hours of just trying things, or you can just read the docs. So we're actually going to start from there today. But today, big topic, big important topic, handling errors in step functions workflows. And you see up there what we're going to be talking about. Why do we handle errors inside the workflow and not inside our tasks? We're going to talk about that. We're going to talk about the fail state in the Amazon state language or in your step functions workflows. We're going to talk about how errors are represented and show some examples of those. We'll talk about retriers, which are the built-in, well, you have to define them, but they're the built-in step functions concept of re-executing tasks on failure. We'll talk about catchers, which are similarly how you catch errors that occur if you want to do something other than retry with them. And we'll talk about the error output just a little bit and how it goes back into that state object. Recall we talked about your state object during the JSON path episode a few weeks back. That is still up and available both here on Twitch and on our YouTube channel. So check that out if you're not really sure how to handle input path, output path, and result path. We'll be talking about them a little bit today, but you should be able to follow along even if you didn't catch that episode. Just know that it's there. And of course, the most important part of what we do here, we're going to build a little bit. So I've got a lot of code to show you today, a lot of simple sample state machines that demonstrate these different retriers and catchers. So let's get into it. Is it that important? It's that apostrophe important. Like this. It's important. There you go. All right, so I want to fire up that docs command, the links command one more time. And you see this Amazon States language link that you have right there. That's that robsutter.tv/ASL. That's where we are here. That'll take you to the Amazon States language website, which apparently no longer has a picture of me down in the bottom. Let's change that. How about that? Yeah, website looks better with me on it, doesn't it? If you go here, you get a couple different things that we've talked about, right? Before we get into this, I said we talk about why do we handle errors in our workflow and not in our compute, right? So why don't you handle it in your ECS, Fargate, batch, Lambda tasks? There's a couple key reasons. The first is that this is declarative, right? So all of the advantages that you get from declarative programming as opposed to imperative programming come into play. The fact that it's defined once and left to us to implement is a pretty powerful, you get that equivalence between what you represent and the execution that you get. So you just state how many times you want to retry something. Looks like I messed up my camera too, y'all. Geez. Wow, it's not a Prime streaming day for me, is it? That's an Amazon joke. Prime. Get it? But so you define the retries in terms of what you want rather than implementing sleep logic and all of this kind of stuff, right? It's also a solved problem already, right? Like exponential back off, number of retries, infinite retries, all of these things are solved problems. And in particular, AWS Step Functions has solved them for you. So use it. Don't try to re-implement. Don't struggle with, if you have one Lambda function in Python and another Lambda function in Go, don't struggle with the disparity between how you do backoffs and retries in those and keeping track of state and all of this stuff. That's what your step function is for keeping track of that state. So this is, we always say that a step function workflow can be like the int main of your serverless application. So let it be that. Let it be that orchestrator of your application. And finally, when you do this in your step functions workflow, you gain a little measure of observability, and in particular, consistency with that observability, right? Because you can enable logging, or you can look back to the states and the transitions as you go through your workflow, and it's all right there. So again, as always, I like to jettison dependencies. I don't like to include them. If you're writing any sort of in-language retry, there's probably a great library that does it for you, but then you've got a dependency on that library, that sub-dependencies on other things, or you can just use step functions, right? You're already orchestrating your workflow with step functions. Go ahead and use it the right way, the whole way, all right? So coming into here, don't worry, y'all. I have read this whole document exhaustively, even though it looks like I only selectively clicked on parts. So trust me when I say I am 100% on having gone through here. Don't ask me any questions. No pop quizzes. All right. Dad jokes. That's right. Dad jokes are the only jokes that I have. Happily a father for just over 1 year now, and my jokes have slid seriously in that direction. So if we go to concepts and states, we said we were going to talk about a fail state. So we have, come on, y'all, I could have done this more easily. Let's go back to the top. State types. Look, it's like the one link that I haven't clicked, and it's the one thing that I wanted to talk about. So novice, 19 years here and 5 kids. Man, I'm telling you, that guy's tenacious and persistent. But if we look at the fail state, there's a couple key things to note about this, right? One, the fail state is a terminal state. So if you get into a fail state, whatever scope of your workflow you're in at that point, that's it. You're done. You cannot catch your way out of a fail state or retry your way out of a fail state. This is like, for my Go programmers, it's like a panic, right? It's not an error, it's a panic. It's, you know what, I don't know how to fix this. I don't know how to carry on. I'm out. We're done here. This is why. And you'll notice there's a couple like definitions here in the ASL page. You must have a string field named error, which means if you don't, then your state machine will fail to deploy. And you must have a string field named cause that you should provide a human readable message in. And the example here is error A in kaiju attack. And the reason that you want to have that is so that you can figure out what happened later, right? Again, when you're debugging, when you're looking back through. And again, like, it's important to notice, I talked about it's the end of that phase of execution for whatever scope you're in your state machine, not necessarily the entire state machine. But that's where some of these nuances come up. If this happens inside of a parallel branch, then it's going to fail the execution of the entire branch, right? Meaning if you have task A on a happy path and task B fails, the entire parallel branch is going to fail. So you need to be aware of that. Even though half of it may have succeeded, there's no way that you can come to a success state out of that. Same thing for when you have a map, if the dynamic parallelism. If you're iterating through items in an array and one of those items somehow through its workflow triggers a fail state, your state machine is going to stop processing. It's not going to get to the other items. So it's important to understand those two behaviors because these are most commonly used with parallel and map states. The third place you can use them is, of course, up top level. And if you invoke a fail state at the top level of your workflow, meaning not inside a branch or a map or parallel state, then your workflow execution is done. It's a terminal state. It ends. And as the ASL site tells us here, that's why there's no next field in a fail state, because it represents like a hard end of the line. All right. Any questions on that? Any questions on fail states? It is not the 51st state. Don't let yourself live in the fail state. It's very useful, but just understand that it is like a panic. So you don't want to fail on an error. You want to catch errors. You want to retry errors. And then if you just continue to be unable to handle them and catch and retry your way out of that error, then you fail when you have no other choice. So be sure that you think about it that way. Let's see, got to get my mouse out of the window and look at my agenda. Error representation. I want to go back up to talk about, oh, wrong window, y'all. Oh, look, I hid myself again. Banner day for me over here on the streams, on the internets. When we go back up here and we talk about errors, Appendix A here on this ASL site, we missed you. I missed you too, buddy. It felt like, it was like when I play with my son and I'm like, peekaboo, and I can't see myself, so I assume nobody can see me either. Magic. When you go to these predefined error codes, I want to talk about the first 4. And we're going to build all of these today. We're going to build catchers for all of these. We'll talk about states.all last. That doesn't work for me. It doesn't work for you. It's because your children have grown up and they're smarter than you now. And mine will be there in about 6 months. When we talk about the timeout, that is when you've provided a limit of execution time on a task, and that task failed to either complete or return a heartbeat. So if you saw the long-running workflows episode where we talk about the wait for task token, you can optionally send back a heartbeat from that task to let the state machine know that you're still computing and still alive, you're just not done yet. And if you define a heartbeat timeout, then and it fails to respond in that time, then that'll throw this error as well. Also, I'm looking through the chat. I'm sorry, Christian Paul. Hola to you, having missed that earlier in there. Am I missing anybody else? Looks like I got that. Task failed is just what it sounds like. When you invoke a task, and we're going to use Lambda functions for this, they can either return an object or they can return an error. And Step Functions is smart enough to understand the difference regardless of runtime. So when you return an error message, it considers that a task failure and it throws this task failed error. I'm using throw somewhat loosely here. It's just, I'm used to that try, throw, catch type terminology. But you can think of it that way. And then finally, states.permissions is the one that I do to myself all the time, because 100% of the time I forget to give my function permissions to invoke my step functions workflow permissions to invoke my Lambda functions, and I get this error and I have to go back for it. And then finally, states.all is a wildcard. So if you use this, and we'll get to this later when we're building, it has to be placed alone, right? So think about like a case or switch statement, and that's what you've got here based on your error type. It's a switch, error, case, timeout, do A, task failed, do B, permissions, do C, default, do X. All right. So those are the 4 that we're going to focus on today. Again, that states.all, when we define our retriers, we define them as an array. It must be the last retrier in the array, because it's like that default case, right? It's only invoked when everything else is done. And when you define catchers, it must appear, and retriers, it must appear on a line by itself, because you can't match case A and everything, right? You just match everything in that case. So that's those. Let's take a look here at what this looks like in practice for these first 4 errors. Any questions here? I guess HTTP connection errors, not timeouts, fails on .TaskFailed code. Christian Paul 00, can you give me a little more information there? Because what are you thinking of specifically there? Because you can't make an arbitrary HTTP call from within your step functions workflow. So you have to have some sort of compute that's invoking that connection. So if it's a Lambda function, it's going to try to connect to some downstream API. It's going to get an HTTP connection error and then do something. I advise you always just throw that error back out. So in that case, you would get a task failed error, if that's the question that you're asking. If you're asking about something else like a service integration, let me know. Like when API call refused to connect to an HTTP endpoint from a Lambda. Yes. So that, yes, it's going to result in, it's up to you to write your Lambda function to throw that error rather than handling it and retrying, which again is the best practice. Just throw the error back out to the workflow. But yes, then you're going to see that task failed code. Unless you define your timeout on that task state to be 30 seconds and it takes 60 seconds for the HTTP connection to timeout, then it's going to be a timeout error. because it won't have failed and returned the error yet, right? So keep in mind, step functions isn't reaching into your compute task. It's not reaching into your function here. It's relying on what your function returns to it. So it's pretty much agnostic about what's happening inside your function. Hope that makes sense there. Buildy. Let's go to the codes. In order, we're just going to handle these in the order that they came up. I don't actually have an example of states.all, I don't think, because it's sort of trivial. But let's take a look here at timeout. And we've got ourselves a simple SAM template with 2 parameters. And all this code will be posted after the show, after I get the YouTube link in there, right? So again, makes sense, good. So again, your, what was it? Was it GitHub or repo? I forget. GitHub, it's GitHub. Right there to find all of these templates after the show. So we have a parameter to timeout in seconds. That's for our state. And then we have a parameter for minimum execution seconds. That's for our Lambda function. And we give it a much longer timeout here, but we pass into the environment that minimum execution seconds. In other words, we want to ensure that our function executes for this long. And again, this is a really simple function here called long running function. And all it does is parse that duration in seconds and sleep for that amount of time, right? So it guarantees that we wait and we come back. And then inside our workflow here, you see that we have our long running function and we define this timeout seconds. This is a native parameter for the task type. And in fact, if we go back here and let's use our hello world and we create, where are our states? If we create a Lambda state here, you see that we can catch, comment, heartbeat seconds. Heartbeat seconds is what we referred to with the wait for task token. And then timeout seconds. Let's see. Heartbeat seconds, we get this nice definition here, right? If more time than specified elapses between heartbeats, it fails with a states.timeout. In comparison, if the task runs longer than the specified seconds, this state fails with a states.timeout. So again, this is just from the episode way back at the beginning of the series on introducing the AWS step function support for the AWS toolkit for Visual Studio Code. Just gives us some helpful hints here when we're creating our workflows. And then we have this catch block here, right? So we haven't gotten to retriers yet. We're going to get to those last. We'll do a simple retrier and a simple catcher. But in this case, we see examples of the catch block. And I was wrong. I actually include a states.all for all of these, and we'll manipulate these so that you can see the difference. So here we catch a states.timeout error, and we move to timeout fallback, which is just returning this error. Or for any other error, our default case, we return to our catch-all fallback. And you'll see that throughout all of these state machines. So I have gone ahead and deployed this to my AWS account. And this is states.timeout. We're just going to start an execution as is. And get me back to my step functions console. Uh-oh, that's red on purpose, y'all, because I need to. It's a very complex example for later. Ah. All right, so we just executed our states.timeout. Or we should have. What happened here? I must have missed something. I'll have to go back. And so we've got this long running function now. And what we expect to happen is for that function to run for 10 seconds. And for us to hit this timeout fallback, and we do, right? So we can see here, this long running step, we caught an error. And that error was states.timeout, right? Super. That caught error took us into the states.timeout exception. So fair enough. That one's pretty straightforward. Any questions on that? Hello, Antonio Ortega Jr. Thanks for joining us today, talking about error handling in AWS Step Functions. All right, so I'm going to go back to the code Oh, I never started the execution. Brain power, y'all. Like I said, Tuesday, what are you gonna do? We're looking for timeout states here. Let's change these parameters via a SAM deploy guided. Keep the same name, same region. If we give it 10 seconds as the timeout period for the state, but we only have the function sleep for 5 seconds, redeploy, this should just be down the happy path, right? So we'll see that that error is actually coming from the parameterization of that state machine definition. And while this rebuilds, let's go on to the next one. Oh no, it already updated. Look at that. Okay, so we'll go back over here and I'll actually execute it this time. You can use an empty function. Sorry, an empty JSON object. And we'll start that execution. We come back to our timeout state machine, and this time we see that, as expected, ran down the happy path to the end, right? So our execution time, as expected, is right at 5 seconds, give or take some overhead. Perfect. It's working as we want it to. Let's move on. Any questions about the states.timeout and how that has two ways that it can be thrown, right? One, you're just doing a normal task and it takes too long to complete, or a synchronous task and it takes too long to complete. Or two, you're doing an asynchronous task with a callback token using wait for task token, and you've defined a heartbeat timeout and your task fails to respond during that heartbeat window. All right. So let's clean up all this stuff over here. Windows everywhere. Get back over here, close this. So that's timeout. Now I'm going to show you task failed. This is more fun because I got to write a failing function. It was very easy. Serverless is more label around my water bottle there. Okay, this one is for the task failed state. Let's take a look at our function real quick, and we're just going to guarantee every time that our task fails by returning an error here. If you're not familiar with Go, I think that should still be pretty straightforward, right? We just return a new error and off you go. Serverless for everyone. I don't have one of those stickers, EDJ Geek. So if you want one of those stickers on my water bottle, you're gonna have to mail me one. Buy stamps, y'all. So this task has failed. And so what we see here is, again, we define that function. We define a simple workflow that invokes that failing function and catches a task failed error and takes us to the task failed callback. Now you'll see this is almost identical to what we did before, right? The value in this is less the demonstration of what's occurring and more the fact that you will have this code to copy paste whenever you're handling these errors in your own state machines, in your own workflows. And a lot of times you'll want them to be complex, right? Where you catch a failure here and do one thing, or you catch a timeout here and do another. Because a timeout might happen from a downstream dependency, but in essence, a failure should probably not occur, like a hard failure. Who knows? It all depends on how you write your functions, but always return your errors. And in this case, we have the task failed callback, and again, the catch-all fallback for the states.all. I will manipulate some of these later so that you can see what happens. Task failed. Again, not a whole lot of fanciness to provide here. I don't think. I probably should have read that. Does it expect any parameters? Nope. And so we can go back to our console. And we'll see that even though our task is failing, our execution is succeeding. Oh, interesting. I must have done something here. Our execution is succeeding because we're catching that workflow. So let's see, failing function, output is an error string. Oh, yeah. So, very important. This is actually what came back, and this error field is, this is a mistake on my part. I know people hate when we do this in streams. The value of that error field, which must be provided, is what is used to determine how you proceed with error handling. So in this case, what we actually wanted was error equals error string. And I did this to myself because of the way that Go handles errors. When you throw back an unwrapped error like that, it just gives you the type. If you wrap it, it throws back a wrap error. So pays to know your runtime better than Rob does, and it pays to pay attention to what your runtime's actually returning. We will fix that. We'll fix a lot of stuff. So now at this point, since it is looking for that error string, then we'll get that task failed once we redeploy this. Build and deploy. I don't need to change any parameters with this one. So we'll just let this go through. Oh, we will fix that. That was about the sticker for my water bottle, wasn't it? Okay. Update complete, workflow. That was fast. All right, we like that. This was task failed. We can invoke it again. Empty object. Empty like my brain today, y'all. And now we'll see that we've gone right down the middle, which is what we expected. We've caught that task failed because its input is the error. Now, I talked earlier, I said in the agenda, we talk about the error output. The error output like this must have that error message and should have a cause message. The cause message should be a string that contains human readable text. The error must be a string, must contain the error name. This error object becomes the input to the next state, and that's whether it's caught or whatever state is specified in the catch, right? You can also have a result path that works the normal way. So in this case, we've done what I call the destructive merge or the destructive overwrite. We've actually, because we didn't specify anything, it replaces the entire state object with this error object. We can change this by getting rid of that and saying, let's see, the catcher may have a result path for this type. Let's say if it's an error string, then result path string error, except I need to be smart about this and tell it where it actually goes. And now again, we just rebuild and redeploy. And what we expect to see now when we invoke this is that we'll keep that same input state that we started with, which is empty in our case, but it'll still demonstrate it. And then we'll create a key value pair where the key is string error in the root and the value is that error object. So let's execute again. Let's see what we get. States task failed. All right, that's us right here. And here we go in with that empty input as we expected, but now we see we have our empty input plus a string error field that we defined, and then the value that was inside the error, right? So the first thing that happens is we look at the error object for this field, and then we determine where to place it. So if you have a really complex input object, you probably want to see that alongside the error and the cause. So make sure that you're availing yourself of the functionality of result path whenever you're incorporating error handling in your workflows. Extremely powerful, makes it a lot easier. I say that a lot, don't I? Extremely powerful. Everything's extremely powerful and nothing is. It makes it a lot easier to debug. So that's the reason to do this, okay? So that is task failed. And now my favorite, somewhat powerful. Yes, it's mediocrely powerful. It's unimpressively I'm trying to just tone it down. It's actually pretty impressive. It's kind of crazy when you think about it, but I do need a new phrase, right? Synonyms are welcome in the chat, y'all. Oops. All right, so that's task failed. Now my favorite, permissions. And I did y'all solid on this one. I gave you instructions on how to unbreak this since I know that it's broken. So for this to actually work, what I've done here, I've given this permission to execute an ARN that doesn't exist. I could also have just commented out this entire policy, right? Give it no policies, give it a role with no policies. This is the proper way. If you do just this, this is gonna work, but we don't want it to work. We want it to be broken. So again, in this case, we're catching on that states.permissions error and moving to permissions fallback. Or we have our catch-all in place. Always good to have a catch-all so that you can do something with your error. You can log it. You can send it to an SNS topic so that you can check errors for your state machines. I mean, there's just like endless numbers of things that you can do as long as you catch them. Rundex, great point on the result path with catch. Thanks for the, I don't even know what to call that, y'all. My brain's burned. Thanks for agreeing with me. Wasted 15 minutes on that yesterday. Sorry to hear it. But yeah, it is very important. And I'm glad it helped. EDJ Geek with a series of adjectives that I can, all powerful, authoritative, capable, compelling, dominant, dynamic, robust. I like robust. It's a robust feature. Anyway, and then we'll get this permissions fallback, right? Because we've deployed this with incorrect permissions. And in fact, we can go look, time is it? We got a little bit of time. Let's dig around, y'all. We can go look at IAM and step functions. This I need to take to Lambda. Okay, so we have these roles that we've created, which I don't know why this is so tiny, but okay, states permission role. And if we look at our policy here, it only has permission to access this real function. So when we try to invoke our uninvocable function with this ARN, ain't gonna happen, right? So let's see that in action. Permissions, start execution. And states permissions. Again, this succeeded with an error. Oh God, again with the catch-all fallback. All right, this one I'm gonna have to go back and rework. AWS Lambda exception. So this one actually threw an AWS Lambda exception. Maybe this is in the way that this is implemented, but that's why it's important to have that catch-all fallback underneath you so that you get it. And then we see that that output becomes the input for this. And then I'll back out of here to retriers. The important thing to remember, and you saw it there, know the errors that you're throwing back. These are sort of contrived examples, and that's why that one didn't work, was because I was trying to force it into that format. Know the errors that you're throwing out, and that is what you're matching here on this error equals field, which is an array, okay? So you can put, you know, my domain specific error and handle it one way. All depends on your, all depends on the types of errors that you already have. Hey bro, I have a question. Why is compute Amazon AWS connected to my network? What is it for? That's a fabulous question. I have no idea how to answer that question for you. And I don't know what you mean by connected to your network. If you believe that that is a security issue, then I would suggest that you contact your account team, file a support request, and ask them. Keep in mind that a lot of apps use AWS compute under the hood. So it may be that some app is connecting to an EC2 instance. but I am not an EC2 expert. So we're going to get out of here from our states permissions, and we're going to go, Cloud9, Elasticsearch, to our retriers. Retriers can be simple, and I'm going to go back to our ASL definition here. Retriers can be simple or complex. The important thing to understand, let me go up top and find errors where we talk about retrying after error. There's a max attempts field, and that's how many times the retrier is going to retry your task. It can be 0, which means that it will never retry. Or in this case, it can be 2. And they give a really good example here, and we've built one as well for our complex retry. Your count for that retry is per error equals state in that state. What do I mean? I mean, let's say you're tracking, and you'll see this here in complex retries. Let's say you're tracking 2 different types of errors, right? Error A and error C. You can forget about error B here for a minute. If you get one error A and then one error C, sorry, you can't see these, and then one error C and then another error A, that's 2 total, even though they didn't occur in order. So you hit your max retries, you don't retry, you go further down the chain. Also, if you're having to implement like a loop pattern, like a loop wait, if you've had to do some sort of back off on your own, once you transition out of this state, that retry counter ends. So remember, you can hit that state inside a parallel branch. You can hit that state inside an iterator, like a map dynamic parallelism state. Once you leave it for that item, that retry resets. So the next time that you come into that iterator, you're starting from 0. This is important for 2 different things. One, it's not a running total of the number of times you've had the error. It's a total of how many times you've had the error inside this state. And 2, if it comes out to a different error but back in again without leaving the state, it's gonna disappear. So we'll come back to this when we do the complex retrier. First, I want to show you a simple retrier. For the simple retrier, I've written a jittery function here. It just get ourselves a random integer, mod it by 2. If it's an odd number, it fails, and we throw an error. And if it's an even number, it succeeds. And so when we deploy this probabilistically, we expect to see, like, sometimes it'll succeed, sometimes it'll fail. About 50% on average. Hello, Darvane21. Thanks for joining us. The meat of this, all right, let's see if I can mute my mic. Excuse me. I'm glad my microphone mute button works today. Again, we just call this jittery function here, but look at this retrier. Let's take each field here. First, it's an array. So we can define any number of retriers here. We can define another one, for example, for error equals states.all, right? Which needs to be quote separate. Whoa, I don't know how I got that there, but all right. States.all, right? So we could do this to catch any error. In our case, we're just looking for that error string error, because again, this is how Go returns an error, and I'll show you another way in the complex retry. So the first thing is we're looking for that type of error. The second thing is the interval in seconds. So we're going to wait 5 seconds before trying again. And for the max attempts, we're only going to retry this a maximum of 5 times. Probabilistically, it can still happen that we get 5 odd numbers in a row and it fails, and you'll see that in the results. And then we have a back off rate of 2, which is exponential back off by a factor of 2, right? So first will be 5, then 10, then 20, then 40, then 80. We all know how this works. Christian Paul, I would love to use retry with back off as the next state for a choice state, not just wait fixed seconds. All right, let me punt here by saying hi, Brown Salami. Welcome to the AWS channel. Thanks for joining us. I get what you're asking to do here. Retry with back off as the next state for a choice state. Not just wait a fixed number of seconds. Okay, so there's timeout seconds when you're waiting for things. I don't understand how you would use, like, a retry is not a state in and of itself. So this is an important point to mention. Both retries and catchers are only for task states, parallel states, and map states, or dynamic parallelism. I don't think it's possible right now. That's correct. It's not, because a retry is not, it's not a state. A retryer is not a state. It's a component of one of those three states. So that's why we only have it with tasks, tasks, parallel, and map states. I would advise you to look back one step before the choice state and see if that matches. If one step before the choice, whatever's populating your state, is that a task, parallel, or map state? And can you put the retryer there? But you're right now it's not possible. But let's look at the executions from this. I've already run this a bunch of times. And then we can see what's happening in conjunction with the logs. So for our simple retryer, we see that we had a couple of these fail, which isn't right. I'm going to show you what happened before. I wasn't handling the error correctly, because I was matching on a different string again, right? So again, it's important to know with your runtime, what are you seeing? What are the shapes of the errors? So in this case, we can see one that looped once, right? So if we look at this Lambda function, it failed. This task has failed. So we go to CloudWatch logs for this particular invocation. And we see, that this task has failed. Look, I got all crazy and wrote it out as a binary so that we can just easily, I know it's easy to divide by 2, y'all, but sometimes I just do things. I don't know what to tell you. Don't do this in production, because it makes your numbers obviously much bigger than they need to be. 8 times bigger if I had to guess. But we see that we got an odd number and we failed. And then later we retried and got an even number and we succeeded, right? So we see these backoffs happening in here, just as we see them happening in our state machine here. So we had one function failure. Look at that, 5 second. Look at, that's exact to the millisecond there. 5 seconds later, we scheduled and then invoked our Lambda function again. It succeeded, and then we succeeded. So then we can look at a couple examples of these. Some will be, I'm just going down these in order. Some will have only executed once. This one slept twice, right? So it ended, slept 5 seconds, failed again, slept 10 seconds. So we see that this behavior is working as we want, as we expect, right? All from this little block right here, right? So again, instead of importing a library, instead of writing the logic to do exponential backoffs and retries and keeping track of how many you've gone through and all of that, we can do this right here. So that's the simple retryer. Any questions before we move on? LolSpark, PogChamp. I'm guessing you're picking up what I'm putting down in that case. Complex retryer then is just the situation we talked about before. It's to show you that your retries are accumulating inside of that state. So for here, let's look at our retriers. If we get an error string, then we define a max attempt of 2, and then the same backoff rate and interval in seconds. But I'll go inside the function in a second here. I've also wrapped an error with a much shorter and a much longer attempt here. And the reason I do this is just to make it probable that we'll get enough invocations that fail on the first retryer before we get to the second. So let's look at what this looks like. Inside the function, and this is just basic, you don't need to worry about this. This is where you would be returning your own errors, right? So if we get an even number, we call that a failure and return a string error. If we get a number that's divisible by 3, we call that a different failure and we wrap it. That's what this does. Don't worry about that if you don't know Go. We wrap it and return it. And then we succeed if we have an odd number that's not divisible by 3, right? So chances are we're going to have one failure most of the time until we eventually succeed. So we're sort of forcing the errors here just to demonstrate that there's a large number of ways to do this. Code looks so neat. Why, thank you. Thank you. That's very kind of you to say. It's all, of course, very simplistic, but I'm glad that you find it easy to follow. So when again, I've executed this one a lot of times over here. And this is one in particular that we got to, that's not it. Did I move off of that? Yeah. Complex retryer that I got to fail. The reason this failed is because we hit our max retries. So remember, in this one, we defined if it's even, only retry twice. If it's divisible by 3, retry up to 10 times. Otherwise, succeed. So we can recognize our even number failures by the fact that they take 5 seconds. So there's one even number failure. And now it fails again, but look, this is only 1 second. So now we've got one even number failure and one divide by 3 failure. And then it fails again. So we get our second retry, and that's the max number of retries. Important point here. Talk about this in a second. We wait 10 seconds, and then we get another failure, and we don't retry anymore. And since we don't have any other catchers set up to handle this, the entire execution fails out. Now, how many times did our Lambda function execute? It executed 4 times. The max retries defines how many times you will execute your function again in response to an error. So if it's 0, you will execute your function 1 time, right? In our case, we said if it's even, retry it 2 more times. So we had 2 retries from an even error and 1 retry from the divide by 3 error. So it's important to note that if you don't want to retry it, set it to 0 and you get 1 try. If you set it to 1, that's 1 additional retry for a total of 2 attempts. The first attempt and the retry. This can trip you up if you're not expecting it. So just make sure you understand what you're doing here. Max retries of 2 means your function will execute possibly 3 times before erroring out. All right. I know I'm like beating that to death, but it matters. It matters to me. So. All right. So with that, that's really all I got here. Unless y'all have questions for me, we can just do a quick review. Do the CloudWatch logs contain any context for which retry it is? Let me see if I enabled logging for this workflow. You know, that's a great question, LolSpark. For express workflows, it may, and I do not know. That may be something that you need to put in there with like a retry counter where you can manipulate the state. The CloudWatch logs themselves are only going to include the information that your function itself logs out. So this is one of the even failure executions. Let me see if I can tie the time here. I think it's that last one that we want to look at. Yeah. Scheduled here. So we're looking at this time, 11 and 22 seconds. 11 and 22 seconds for the last event. So this is our log report there. Let's look at these last ones. 22 seconds is when we start here. That's a task success. So this will be the... Here's where we start. on that one. Odd number not divisible by 3. Task fail with even number. No. So again, we're only seeing, I changed this one to not log out in binary because I didn't feel like trying to do divide by 3 in binary. So we see this is an even number and we fail. The only information that comes in here, as you see from that execution, even number, error string, null, is the information that we log out. So I don't know about express workflows when you're logging. I didn't set one up that way. Let me see. We got 10 minutes. If there are no other questions, I'm just going to try to do that. And let's see what happens. Let's build. Create a new step function state machine. I always forget shortcuts, y'all. Where's the... It's not in there. That's not what I want. Here's how I find anything I need in the docs. I need to know, I can't remember what's the, I think it's type. State machine type express. So we're going to change this. It's going to delete. But I haven't configured logging for this. Let's just see. Y'all give me a second here. I'm gonna be off screen stealing some of my own code from myself, but I don't remember where it is, so I gotta hunt. Oh man. There we go. All right, fear not. Login configuration, destinations. Okay. So login configuration looks like that. I need to go down and define this app log group since we've made this express workflows. So app log group I can define right here above our state machine as another type of resource. Express workflow name, where's it? Oh, that's from a parameter. So we can just call that this. I'm gonna deparameterize that real quick. Attention in days 7, and then my role needs the ability to create and put logs. Thankfully, I can steal this from myself. By putting those in. Awesome. Okay, so what we did, I do this very specific, y'all. I don't like stars. In this case, you have to because there are no resources defined on these actions, but I don't do like logs star for everything. Get log app log group. I think I got enough in there to do this. Let's see, where are we? Complex retryer, right? So let's see what happens here. It's either going to go really well or really poorly. But the basic answer to your question was, for the standard workflows, was no. They don't appear to. I don't know if this deploy is going to work, to be honest with you, because you have to delete. Like, you can't convert a standard workflow to an express workflow. I know I've tried this before. I don't remember how CloudFormation and SAM handle it. If it doesn't like it, then we'll delete it and recreate it. It's no big deal. But we got our log group, we got our role modified. And then, yeah, this is where it's getting weird on us. Any other questions from anybody while we wait for this to deploy? State machine IAM role is not authorized to access the log destination. All right, it's interesting. It's rolling back now. Let me punt on this one for now. Whisper to me here, or let me put up my thanks window, or DM me on Twitter so that I can follow up with you on this. I will take this offline and try to convert that in C for express workflows, but I don't know the answer off the top of my head. That would be the only case where I could think of it. Again, you would need to, like a best practice if you want to do this with standard workflows, you'll need to carry that retry information through somehow. Again, when you consider this in the context of like a real world application where you're considering things like idempotency and not wanting to apply the same operation twice and all of that, maybe use a DynamoDB table as with expiring IDs as like a transaction attempt counter or something like that. I don't know. There's as many different ways to handle this as there are like programming theories, but I will get you a direct answer on that for express workflows. I don't see any questions from anybody else, so thank you all for joining. Oh, wait, Knight. Oh, where could I go to learn about everything you are doing? Well, a lot of places. Go, AWS error handling, etc. Okay, so this was specific to error handling for step functions. Here on all these links, there's this series playlist link there. That is all of the episodes that we've done here for step functions. App 2025 link there is another series that I do on sort of apps of the future. So there's a lot of step functions, Amazon Event Bridge, Amazon SNS and SQS, some other good things there. If you want Go, I think, let me see if that link goes anywhere. If that link goes anywhere, nope. General Step Functions docs from Julian R. Wood, that's right. Okay, there's a workshop here at this link. If you want to learn how to build and debug Lambda functions in Go. If you want to get started on AWS, do we still have the getting started command here? Is this official? It is official, Ben Tennyson G. I am an Amazon Web Services employee. This is the official AWS Twitch channel. Thank you for joining us on it. Thank you, Christian Paul, for being with us. Thank you, Rundex, for being with us. Appreciate your time. Yeah, the AWS Serverless YouTube channel. Thank you, EDJ Geek. Thanks to, I think I said thank you to Julian R. Wood for dropping that link in there. We'll try no choice match for my previous question about choice and retry. It's not going to work. Those 4 states that we skipped are not in step functions, even though they're in ASL. So you're going to need to catch them under all and then look at the way that they work. Again, yeah, LawSpark, you're very welcome. Please, my Twitter's up there. My DMs are open. Ping me on Twitter. I'll get you an answer so I can follow up with you. My green screen is seriously on point. I had a genius helping me out with it, and I think his Twitch username is EDJ Geek. So if y'all need help with your green screen, that's the guy. You want to harass him for that. What else? I think I got to Night. Oh, I think I got answers up for all your questions on that. Again, everyone, this has been AWS Step Functions. We have only a couple more episodes left in this series, and then a few more episodes left in App 2025. If you're interested in serverless more generally, we have the serverless first function coming up. If one of my moderators can drop a link in here, that would be awesome. I'm trying to find it myself. Serverless first function. Free to attend. It's official from us at AWS. There you go. Register for that. It's coming up. It's across 2 days on the 21st of May if you're an IT decision maker, on the 28th of May if you're a builder, are probably going to be the way that you want to focus your time there. I assume most of you are builders, so probably the 28th you want to do it. It's my colleagues and I, a series of sessions. It'll be here on Twitch, so your username and everything that you've already got is good enough. Again, as I said, it's free. We'll be here live to interact with you throughout the day, throughout both days. So definitely check that out. Get signed up for that. Serverless for everyone. I appreciate your time. I thank you so much for joining us. And now go build some cool stuff. All right. Thanks, everybody.